Welcome to Study Loop.
This is a very good problem on geometric probability. So basically we have a square. So this is the square with vertices 1 comma minus 1, 1 comma 1, minus 1 comma 1, minus 1 comma minus 1. Now if I throw you a dot inside the square, we need to figure out what is the probability that the dot falls nearer to any edge of the square than to the center of the square. And what is the center of the square? Origin. Origin is the center of the square. Okay. It's a very interesting problem. So what we do is we'll take one part of the region. So let me join these two. This straight line is y equal to x, and whereas this straight line is y is equal to minus x. Now what will I do is I'll construct a curve which is equidistant from origin. I'll construct a curve such that any point on it is equidistant from this line y equal to 1 and origin. So basically, if you remember the definition of parabola, the parabola is actually a locus of point which moves such that the ratio of its distance from a particular point to the to the distance from a particular line, fixed line, is always 1. And that line is called as a directrix and the point is called as a focus. For example, this is a parabola, this is the directrix, this is the focus. So if you take any point here, this distance, okay, I've drawn a little far away, sorry for that. So suppose, let me take a parabola like this. Yeah, this is a parabola. So now I will take a directrix here. So if this is a focus, so if you take this distance and this distance, so they will be same. So if you take any point and measure distances from focus to the directrix, perpendicular distance from the directrix and the normal distance from the focus, they'll always be equal. That is the definition of the parabola. Now what will I do is I'll construct a parabola passing through these 2 points. Which 2 points? These are minus 1 comma 0 and this is 1 comma 0 because this is my x-axis. And the parabola looks like this. This is the parabola and it passes through some point here that is midway between 0 comma 0 and 0 comma 1. So what is that point? 0 comma half, right? And call this point as A. Now if I throw a dot, if it falls here, then it is nearer to the center because it's inside the parabolic region. But if I throw a dot, if it falls here, then it is nearer to the edge because any point in this region, so I'll just plot this as a shaded region. Yeah, so this region, any point in this region will be closer to this edge. Symmetrically, any point in this region will be closer to the same edge. So it's enough if I take this particular triangle, that is enough. This particular triangle if I consider, then I'll get the probability because everywhere the same symmetry will be there. Okay, now I'll draw this diagram more clearly in the next page. So that means we have a square like this. So this is our square. This is our parabola and this is my y equal to x line. So this is my y equal to x line. So call this as this point is A, right? This point is A, this is O, this is M, this is N. Now we need to find the area of this region. This region, okay? Because in that region, any point, any dot which falls in that region will be closer to the edge MN or the edge of the square, y equal to 1. Alright. Now what is the equation of this parabola? This parabola is basically passing through minus 1 comma 0 and 1 comma 0 and it is opening downward and it is passing and it is cutting y-axis at 0 comma half. So it's very easy to find the equation of this parabola. The equation of this parabola should be of the form x square is equal to a plus by, because every parabola is a quadratic, right? And since this parabola is opening downward parabola, I can always consider the parabola in the form of x square is equal to a plus by. Now how to find a and b constants? If you see here, it is cutting x-axis at how many points? 2 points, minus 1 comma 0 and 1 comma 0. So x-axis means put y is 0. So when y is 0, x square is equal to a. But what is x coordinates? Minus 1 and 1. So minus 1 whole square is 1, 1 square is also 1. So a value is 1. So this is a value. So that means my parabola is x square is equal to 1 plus by. Now where it is cutting y-axis? 0 comma half. Put x is 0 and y is half. So x is 0 means 0 is equal to 1 plus y is half means b by 2. So what is the value of b you will get? B is minus 2. So that means my equation of parabola is x square is equal to 1 minus 2y, or I can write y is equal to 1 minus x square by 2. This is my equation of parabola. And we are very much interested in finding the point of x coordinate of a, because we need to find the area. So I'll tell you how to find the area. So let's find x coordinate at a. So x coordinate a is nothing but the point of intersection of this parabola with this straight line ON. What is this equation of straight line ON? Y equal to x. So let's solve both the equations. So equate y equal to x and y equal to 1 minus x square by 2. So I'll get 1 minus x square by 2 is equal to x. Cross multiply, you'll get a quadratic. X square plus 2x minus 1 is 0. But if you can notice, you should take only a positive x because it is in first quadrant. So x plus 1 whole square is equal to 2. X is equal to root 2 minus 1. So this is the x coordinate at a point A. Now, what is the area? So I'll just shade this part. What is that area R dash? So area of R dash is nothing but by integration. So integration from where to where? From 0 to the x coordinate of A, which is root 2 minus 1. So 0 to root 2 minus 1, which is the curve above that. It is parabolic curve, that is 1 minus x square by 2, 1 minus x square by 2 minus what is the curve below it? Y equal to x, because we need only this part. We are not interested in that below that y equal to x, right? So it is minus x. So this is the integration we need to do. So let's perform this integration first. So what is integration of 1 by 2? It is x by 2. What is integration of x square? It is x cubed by 3, but by 2 is there, so by 6, minus what is integration of x? X square by 2. So now let's substitute 0 and root 2 minus 1. For 0, anyway it is 0. For upper limit, you'll get root 2 minus 1 by 2, right? Minus root 2 minus 1 whole cube divided by 6, okay? Minus root 2 minus 1 whole square divided by 2. We can actually take root 2 minus 1 by 6 common. Then I'll get 3 minus root 2 minus 1 whole square minus so 6 means 3 times of root 2 minus 1. So this you can simplify as root 2 minus 1 by 6 into 3 minus root 2 minus 1 whole square is 3 minus 2 root 2 minus 3 root 2 plus 3. So basically you can simplify this as 2 root 2 minus 3 2. So 3 minus root 2. So when you multiply, so let's multiply it, root 2 minus 1 and 3 minus root 2. So I'll get by 6. So 3 root 2 plus root 2, 4 root 2 minus 2 minus 3. So 4 root 2 minus 5 divided by 6. So this is the area of the region R dash. So area of R dash is 4 root 2 minus 5 divided by 6. So area of R dash is 4 root 2 minus 5 divided by 6. But we are interested in which area? We need only this area, this dotted area. I'll call this as region R. So what is area of R? Area of R is nothing but the area of triangle OMN minus area of R dash. So that is nothing but, what is area of triangle OMN? Area of triangle OMN is, if you can see, this length is 1, this length is 1. It's a right angle triangle, so it's half 1 into 1. So it's half minus 4 root 2 minus 5 divided by 6. So when you take LCM, you'll get 8 minus 4 root 2 divided by 6. So this is my area of R, the region R. Now we need probability, right? So the probability is nothing but, so the probability is given by area of required region R divided by the total area of triangle OMN. because I am taking only one symmetrical part. Only this part I am taking. Only this part. So we have calculated the upper part of area, that is dotted area R. For probability, I should divide by the total area. The total area is a triangle area. So triangle area is how much here? Half, right? So 8 minus 4 root 2 divided by 6 by half. So if you can simplify this is 8 minus 4 root 2 by 3. Approximately this is 0.781. So that is the probability that when you throw a dart, it will be, like falling nearer to edge than to the center of the square. Very interesting problem. Very interesting problem. Thank you so much.